Welcome to Homework Lib.
Hi, so for this problem we are asked to, using the energy just calculated in question 4, calculate the total heat required to heat 180 grams of water from minus 20 to 120 degrees Celsius. So I am assuming that the energies you just calculated in question 4 were for calculating the specific heat or for something else. But regardless, the formula to get the amount of heat that we require to heat up water or that water is releasing when it cools down, it is going to be the mass of water times the specific heat capacity of water times the delta T. In this case, delta T it is going to be positive. Let's remember that the value for the heat capacity of water it is going to be 4.184 joules per gram per degree Celsius. In this case, it doesn't matter if we're using degrees Celsius or if we are using Kelvin because the delta T takes both of them into account. Recall that the transformation from Celsius to Kelvin is just adding a number. So when we take into account the delta T, that number is going to be cancelled on both of the sides. So we can use directly the delta T in Celsius. Remember, delta T is T final minus T initial. In this case, this is going to be 120 degrees Celsius. That is going to be my final temperature minus 20 degrees Celsius. That is the initial temperature. So with this, the resulting value is an increase of 140 degrees Celsius. The amount of mass of water that we have is 180 grams, and the units already match up with my units for C. Another way to get this value is you can also find it as 1 calorie per gram degree Celsius. Both of them are equivalent and you can transform it directly. So we're going to do it in joules because that is the units for international system. We have the mass times the heat capacity, 4.184 joules per gram degree Celsius, times delta T, that is 140 degrees Celsius. Let's cancel the units. Degrees Celsius cancels with degrees Celsius, grams cancels with grams, and our final result for this is going to be 105,436.8 joules. Now, if we were to do this in calories, first of all, we can also transform this 0.44 kilojoules, round it up to the second significant figure. If we want to do it in calories, then the result it is going to change due to the heat capacity. We said that in calories, this is 1 calorie per gram degree Celsius. And delta T stays the same. And for this, the result is 25,200 calories, which is the same as 25.2 kilocalories.